Alright, so we've got a composition of the cosine function and the inverse tangent function, but there is no number on the inside of the inverse tangent function. So what we do here is the same process. We say the angle is the inverse tangent. Inverse trig functions are angles. So I'm just setting it up as if that's an unknown angle. And then I'm taking the tangent of both sides and saying the tangent of the angle is just this u. Right? But similar to what we did in the previous video, we're going to call this u over 1. Because it's tangent, this is the opposite, and this is the adjacent. So when I draw my right triangle, and I'm just going to label this theta, there's my right angle. Opposite of the angle is u, the adjacent side is 1. And so the Pythagorean theorem would say that this hypotenuse squared is the legs squared summed together. So 1 squared plus u squared. Alright, 1 squared is just 1, so I'll just write that as 1. So h squared equals 1 plus u squared, and so h is then equal to the square root of that. Alright, now we're going to solve for cosine. The cosine of this angle is equal to, cosine is adjacent over hypotenuse. So that's 1h, and h is the square root of 1 plus u squared. So that's how I could come up with an algebraic expression that's equivalent to this cosine output. Alright, so there's my output. We don't need to simplify, meaning multiply top and bottom by this square root. We don't have to rationalize the denominator, so that's perfectly fine if you just leave it in that form.